Yes, good evening, everyone.
Good
Good.
evening, sir.
My screen is visible to you.
Yes, sir.
Yes, sir.
All right. So we'll discuss few questions that you have given to me. Okay. The first one that we are going to discuss will be your regarding air compressor. Okay. So few questions were there regarding air compressor, then few regarding your boiler, and one more thing. We'll see. Okay. So air compressor. So we have to discuss what is FAD. What is the full form?
Free
Free
air
air
delivery.
delivery.
Free air delivery.
Yes. Free air. Yes. Okay. So this term is used to compare, the capacity of different compressors, okay, under different conditions. Okay, suppose I have two compressors. Okay, number one compressor. This is one compressor. I have second compressor over here. Suppose this compressor can compress pressure about, for example, up to, let us take an example, 50 bar. Okay, so the pressure that it can P1 pressure that it can produce, it is 50 bar of pressure. Then I have a volume. What volume it can give? Volume, suppose for example it can give 35 meter cube. Okay, if I take the temperature after the end of compression, for example it is compressing, after compression the temperature is around 110 degrees Celsius. Okay, and I have a second compressor which is able to compress the pressure of about 75 bar. Okay, the volume will be obviously will be less. Volume will be, let us take 25 meter cube, and a temperature at the end of the compression is coming approx on 30. Okay, so if I need to compare these two compressor and I want to figure it out, what is the capacity of the compressor, which compressor is better for me. So what I have to do is I have to check the free air delivery, and I have to convert these two readings into, I have to convert it into 1 bar at 15 degrees Celsius. Okay. In some books, you will get it 20 degree also. Okay. And this also I have to convert it into 1 bar at 15 degrees Celsius. So if I have to find out, about the efficiency of this compressor, or about the capacity of this compressor, so I need to start from some base, right? अगर हम कोई रेस करते हैं, if I'm doing a race between two guys, so initial point should be same, isn't it? Then only we'll be able to come to know who's better, who's not, right? So this is what we are going to understand here in free air delivery. Okay, that we have to convert it into a uniform state, and then from there it will be easily, we can make out which compressor is a better one. Okay, is the base clear?
Yes, sir.
Yeah. Okay, so what I can write about it is, this term is used to compare. They asked me this in class 4.
Yes, sir.
Okay, so actually a class 2 level thing. Handling capacity of different compressors.
सर
Working
तो
under
आज केवल क्वेश्चन आंसर सेशन चलेगा ना?
Yes, working under different conditions. Okay, so I have these two compressors, number one and number two. They are both working in different conditions. So if I have to figure it out which is a good compressor, I have to start from a, I have to have some initial point, right?
Yes, sir.
Agreed? Yeah. So the volume of air when compressed, okay, when converted, after compression, when converted when converted to 1 bar, I have to give initial value to them, right? 1 bar pressure at 15 degrees Celsius is referred as free air delivery. All right. So, अभी why it is important? Free air delivery हमें क्यों why we should know about it? Because with this we will be able to select our compressor more in a better way. Okay, which compressor will be required for the ship's application? What will be the ambient temperature over there? Okay, and what will be the ambient pressure over there? So this all things comes into it. Okay, and also it gives you more realistic indication of your compressor performance. Let us write it down that point also because this is important. So FAD is a measure or measures the actual amount of compressed air produced by compressor under specific condition. So now here it is written, I have written the actual amount of compressed air. What does it mean? Do you remember effective stroke in compressor?
Yes.
Yeah.
BY
Yes, sir.
and EY.
Yeah.
Effective stroke का
So yeah, effective
numerator.
stroke. So that is what they are mentioning here, actual amount of compressed air. Okay. So we will see later on, okay, about this thing also. Let me write it first. And understanding of FAD, okay, is important for selecting right compressor for application. Okay. Also, FAD provides more realistic indication of compressor performance. Higher FAD value indicates that compressor can deliver more air. Okay, so that means this compressor will be, if your FAD value is more, that means that compressor is more efficient. Okay, so I took an example of two compressors in which I've told you these compressors are different compressors. Now, in order to find out which compressor is more efficient, which compressor is more better, I have to start from some initial point because these two compressors might be working in different temperature regions, and also these are of both different capacities. So if I have to compare these two, I have to start from some initial points. For that, I have to convert these values. Okay. I have to convert my pressure and temperature, okay, to the standard what they have given, that is 1 bar and 15 degrees Celsius. If I convert it, will I be able to find my volume? How much it can give me the volume of compressed air, right? So you might everyone know about PV equals to MRT.
Matter.
Yeah.
Yes, sir.
What is P? Pressure.
Pressure,
P
Volume.
is volume. What is M?
Mohs
Mass.
constant.
Motor.
Okay. What is R?
Reynolds is a gas constant. Gas
Gas
constant.
constant. And T is your temperature.
Temperature.
Right. So if I take first of all the PV diagram of it. Okay. So what the PV diagram we discussed about something like this, isn't it?
Yes, sir.
Single stage compressor PV diagram is like this. Double stage it will be different one, right? But this is only compression has happened, the volume has reduced and pressure has increased, right? And this is the discharge part. But what about after discharge? Again, expansion will take place, right? So if I have to draw the complete PV diagram of the cycle, complete cycle, so then I have to draw it like this. Where from 1 4 to 1 will be
Section.
suction, then 1 to 2 compression, then you have discharge, and then you have expansion. Agreed?
Expansion.
So what is this thing over here?
Clearance volume.
Then
Clearance,
volume.
yeah,
Clearance volume.
clearance volume. What is this one?
Atmospheric pressure.
Atmospheric
Yes,
pressure.
yes, atmospheric pressure. Okay. Now we know PV equals to
And
MRT, and you should understand that mass will remain constant. Okay, before expansion, before compression, and after compression. Okay, so suppose I have used a compressor. Okay, this is my inlet. Okay, this is the inlet, and this is the outlet. So the amount of mass of air it is entering here, the same amount of mass is coming out of here. Do you agree?
yes, sir.
Yes, sir.
The amount of mass of air it is entering inside your what you say
Compressor.
cylinder, okay, or your compressor. The amount of mass will be same, only the pressure and volume will change, isn't it?
Yes, sir.
Mass will remain constant. Okay. So if I equate it, so P, if I take of ambient, okay, A and B is ambient, okay, or you can say the atmospheric one. V ambient upon T ambient will give me volume. Oh, sorry, will give me mass ambient पे.
Yes, sir.
Yeah. Similarly, when I'm going to compress this air, when I'm going to compress the air, okay, so what I will get, pressure will be after compression. Okay, sorry, at before compression, the pressure is P1.
Ambient. P1.
Okay, what is my volume?
V1.
V1.
Volume will be V1 minus V4. Actual volume, है ना? The actual volume
No.
will be V1, V4.
Yes, sir. Yes, sir.
Yes,
Okay,
sir.
see this one. If थोड़ा सा इरेज करूंगा, ठीक है? Okay. Now you see from here to here only the actual suction has happened. Do you
Yes,
agree?
sir.
Yes, sir.
ये effective stroke है ना sir?
Yes. Okay. So it is V1 minus V4.
Yes, sir.
Yes, sir.
V1 minus V4 क्यों? Volume 1 ज्यादा रहेगा ना?
Yes, sir.
हाँ sir.
Compression. Not.
This will be V4. Do you agree?
Bumping theory.
Okay. So
Yes, sir.
divided by temperature, okay, which is T1, okay, temperature is T1, and this is equals to mass, that means actual suction. Now I said you that mass will be
The
equal,
same.
Constant.
right? Mass will be equal. So what it will become? P ambient, V ambient by T ambient is equals to P1 V1 minus V4 divided by T1. So what my V ambient comes is V1 by P ambient
P1.
multiply T ambient by T1,
T1.
agreed? Multiply by V1 minus V4, and this V ambient what we are going to find out, जो हम conversion कर रहे हैं, this is what is known as your free air delivery. ठीक है? V ambient is your free air delivery.